good way of understanding what telecommunications is to us is to start with what we originally thought it was. So the first thing that comes into my mind when I think of telecommunications is just like 5G or Wi-Fi. It's these invisible protocols around us that are moving data. But I think through both this project and just my learning in general, I've kind of come to realize that telecommunications is more about how we're moving all this data in the info age just in general. And that includes things even just like what we did with this project, which is, using this coax cable and literally a coat hanger antenna and being able to receive images from a satellite that's 800 kilometers away, moving at 17,000 miles an hour. So it's just that way of getting data from medium to medium, and it's in the physical world, it's all around us.
One of the first things I realized about telecommunications is that it's all physics. I first noticed this while calculating the resonant length for our antenna and matching it to the 137.9 megahertz signal. This project also showed me that the physical layer is the foundation for everything within telecommunications. If your antenna impedance doesn't properly match to your transmission line, the signal, and therefore the data, basically cannot even exist. Even small design choices matter. Something as simple as adjusting the antenna angle to a 120 degree could be the difference between receiving clear, high-resolution image of Earth or something just like static. I also started to understand concepts of electromagnetics and how they applied within telecommunications. And this made me realize that telecommunications itself is not just like a subset of electrical engineering. It's incorporated into a bunch of different parts of like making sure you have like circuits that can power these different communication methods, and making sure like the signals within them are like working as they properly should. And that balancing all of these isn't just theory, it's how we can make communication possible while working within the laws of physics.
Yeah, and a big part of telecommunications and our project specifically is that idea of optimization. And so the Georgia Tech thread page for telecommunications mentions engineering and optimizing systems. And in our context for this project, a lot of our optimization was, fighting the noise floor in Atlanta. There's all these signals going around us, blasting around us, whether it's FM radio or your laptop or your phone emitting electromagnetic waves. So that can all interfere with how we're able to receive signals and interpret them. So there was a lot of optimization there, whether it was setting our sample rate to something else, whether it was trying to tune to different frequencies or different decoding protocols. So there were a lot of decisions to be made, and I think it's really kind of the idea of telecommunications and the people who are doing telecommunications engineering to be able to decide what to optimize and how to do it.
This project made me realize how telecommunications operates on a global scale. The technologies we're learning about in this site aren't just theoretical. They form the backbone of the entire information age. Every text, call, or piece of data depends on systems that are designed, optimized, and maintained by engineers. What stood out to me is how accessible it is. I was able to build a functioning satellite for just under $50, and it really changed my perspective of something that seemed like so far away and inaccessible to and being controlled by just large companies, but it's a tool that can be used by anyone. And this has real world impact. Systems like these are used in disaster relief when traditional infrastructure fails, in remote research where connectivity is limited, and environmental monitoring to track changes on a global scale. We need new innovations in creating cheaper telecommunication systems and more robust ones, and ones that we can get out in a fast-paced manner. And understanding how these systems work means that we can design networks that are more resilient, more efficient, and more accessible to everyone, everywhere.
Yeah, and to put it all together, I think telecommunications is really that bridge between mathematical formulas and that ability to receive images from satellites up in the sky. It's really solving that constantly evolving puzzle with all these different factors you need to take into account that really just ends up keeping us all connected, all this data moving around, and how do we receive it, and how do we send it, and how do we do all of that efficiently. And I think this project was a really good first step into that domain, and it really proved that the sky's not the limit with these kinds of things. Even with just some off-the-shelf components and things lying around the house, we were able to have a really successful time linking with the METEOR satellites and getting those images.